Yeah, we are now recording this presentation as well, so you can see that recording.
Yeah.
All right, so within the specific disciplines, we have a very bright pool. So we have a couple of different tracks. We have students who want to go through the mechanical engineering track, aerospace engineering track, and biomedical engineering track. Those are all different, and you go in different directions after you leave our program. But while you're in our program, you are still taking the same fundamental core courses. You obviously have your foundation of engineering, but then students in these tracks wind up going in statics their second semester, and then mechanics, materials, circuits, and dynamics in their second year, which are all core classes that are really taught everywhere in the country, and really important for those specific things. Next to that, we have our civil engineering track, which is similar. You take statics your second semester, and then mechanics, materials, engineering, econ, and dynamics. The only difference there is our civil engineers don't need to learn circuits, instead they take engineering econ, so they learn more about project budgeting, so on and so forth.
So within these two tracks, I brought up, this is just kind of one of the projects that we have our students do. So when they take statics, they have to solve a problem, basically finding different loads applied on the truss. Then we give them this, well, they can come and do this. They actually set up different load cells, and they can actually prove, did they do their calculations right? So not only are they learning like the hands-on, the calculation piece of it, but we try to incorporate this hands-on piece too. I bring this up with civil, mechanical, and aerospace and biomedical, because even though they're all taking that, these fundamental things are important for all the tracks. And this is something that we really try to incorporate as this hands-on stuff. So if a bridge like this interests you, then maybe civil or mechanical or aerospace might be great.
Our last two tracks are actually the same track, electrical / computer engineering. I think we take quite a bit of different courses. Semester we'll take computer programming for engineers, and then they'll take computer engineering, and then circuits 1 in their third semester, and then circuits 2 in their fourth semester. So we're working on learning to program computers, microcontrollers, and then build circuits, test circuits, and understand electronics. So those are the different tracks that we have and the courses that we offer, those specific electives that we offer for those tracks.
Any questions on this?
All right, so now I'm just going to go through a couple of pictures that we have from the different courses that we just talked about, starting with engineering design. Engineering design is a really fun course. We're running it right now, where we teach students about what an engineering drawing is and how to use CAD software, computer-aided drafting, such as AutoCAD and Inventor, to build objects and design solutions for problems. And we go through the basic fundamentals of what an engineering drawing is, and then they're given a semester-long design project that they work with a group to solve a problem. And this is an example of last year's engineering design class. This group, just as an example group, built basically an Arduino Game Boy that has an LCD screen, 2 push buttons, and then a microcontroller into that. And they program the microcontroller to operate the game. And you have to actually design the 3D structure that's going to house everything together, which you can see here in red. And it's designed, exploded through over here in Inventor. And then you have the actual group itself with their finished product over to the left. And that's actually, we have the 3D printers going in the back. Here's design teams are working on a bunch of different projects. And we just had class, as I mentioned, and they, after class, started a couple of new prints. So it's a really fun class. Every student really enjoys this. And you get to really see that rapid prototype process of, we have an idea, let's build it, didn't work as we intended, let's debug, figure out what went wrong, what we can improve, accelerate that, modify, and then next week we have our next prototype. So they really get to see that full design process. And it's a course that you really learn the science and art behind developing a system that truly has software, hardware, and housing to it. So you have to have multiple electronic devices all communicating and working nicely with one another, and then software to control them, and then some sort of how hardware to house it all together, nice, neat, finished product. It's something that really is quite tricky to learn, but it's a fun course.
Probably would, it's, I think it's my favorite course.
It's a lot of fun. And we primarily work with Arduino controllers for that, where you're developing software in C++, uploading it to the controller in order to interact with the system. So it's engineering design. Every student in our program will take engineering design. This is ER 245 Dynamics. This is taken by our mechanical, aerospace, biomedical, and civil engineers. And broadly speaking, dynamics is the process of solving Newton's law, F equal to ma, and relating forces in motion. So we figure out how something's moving and then calculate what were the forces in order to get it to move back to that direction. So on and so forth. And these are just some examples. So we, like Professor Powell mentioned, try to incorporate a lot of projects into our courses that will help students understand the content, verify their calculations, but also just see what they're learning in the real world, whether that be a real experiment or some type of simulation software. So one thing that we'll learn in dynamics is energy calculation. So if we have a system that has stored energy in a spring and release that spring and that's transferred to kinetic energy, how does the system respond? So taking that, a very basic calculation that we do quite a bit, we built a physical catapult that is an extension spring control that you can see over here on the right. We have a spring that connects that red point to that red point, and as you pull it back, it has a tennis ball stored in it. You release, and it launches the tennis ball forward. So we physically built that system that really replicates what we were learning in the classroom, so that we can see do our calculations actually predict what the system is going to do. We measure how the system performs, and then we also developed some mathematical modeling and inventor simulations where we actually add the system up and run a simulation to see how that simulation is made. All in ways to understand the content and understand how we can apply that. The simulation side is something that is really, really, really useful for taking what you're learning now and applying it to the next step in something in your career. Obviously, a lot of very fundamental engineering courses. We just have something like a brick that's sliding across the roof. It makes some sense. You're able to learn the calculations, but it's very, very, very simplistic. As soon as you get out in the real world and you start thinking about, I want to design a crane or a skyscraper or something that is really big, truly in 3 dimensions, has very complex loading behaviors, movements, doing all those calculations by hand is quite challenging. So moving to a simulation software is very common in industry. So we try to incorporate some of that software into our curriculum to help students start learning that at early. And this is our circuits class. So circuits has a lab component to it. The other class didn't have a formal lab component. There's just some projects that we like to incorporate throughout the course. Circuits has a lab that meets every single week where the students are building circuits that they are solving by hand in their course, and then actually experimentally measuring those circuits either with a oscilloscope or a multimeter or a type of device. And so this is a little bit more of a traditional type project. Here you have a student to build a circuit, measuring it with an oscilloscope, and over the right way of student learning how to solder a circuit together in something that's a little bit more permanent and just consistent on a work. I believe this is our last slide for the engineering transfer portion of the program. Are there any questions for the fund? So we have a question. The course is showing you need to take all the classes shown in a semester, or you can take 1 or 2. The tracks we showed were really our suggestion, and like the ideal timeline. If students do need to kind of split things up and shuffle the schedule around, that is definitely possible. But there are, you just have to work with your advisor on that, because there are definitely courses that have prerequisites to them or co-requisites. So there is an order you can take everything in, but the exact timeline.
Yeah, and we have students who, if you're working and maybe you don't think you can handle a 16 or 17 credit semester where you're taking 5 classes, especially some of the challenging classes, we have ones who split it into 3 years. Or for, like typically they're here for 2 or 3 years. If you come in with a lot of credit, take Calc 1 and Calc 2, maybe physics in high school as well. We've had maybe a few students do it in a year, but typically it does take 2 years just because of the sequencing. You have to have statics to take dynamics and strength materials. You have to have physics 1 to take physics 2. You have to have calculus to take physics. So it all kind of stacks. But there's no reason you can't lengthen that amount of time. There are very few students who get it done in less time, but we've seen it. Any other questions with the transfer program? We can do that.
Yeah. Yeah. So now we're going to go through the engineering technology sides. We have 3 different degrees that are associates of applied science in general engineering technology, and for engineering specialization, civil engineering specialization, and then computer-aided drafting specialization. We're going to go through what the curriculum looks like for all of those degrees. And then we have 2 certificates, one in land surveying and one in drafting.
So the engineering technology program in general, it's really meant for students who want to get their associates and start working, or be working and getting their associates. We have a lot of students who are working full-time who are in this program. Most of the courses are evening courses for the engineering technology program, just because it does allow for students who have those full-time jobs to actually still get their classes and still get this associate. There is a lot of flexibility in the classes, so we do have evening classes and we try to offer high flex. High flex meaning that we have students who come to the classroom to take class. We also have students who attend class virtually. This is one of our high flex rooms, which usually works every day of the semester, except for this evening, but we have backups to our backup. As engineers, we're good problem solvers, so we're able to figure that out. But the flexibility with the classes is important. And we have businesses that actually go through this curriculum twice a year with us. So we walk every single course our students are taking and say, are they getting what they need out of their associates? And most of them can answer because they've hired our students. We have students that are working for them and that they can see how what they're learning in the classroom, they're able to apply it or not apply it to their job. And they can help us with the curriculum and guide them. So this is a picture of one of our surveying classes, and the surveying class, they do their labs on Saturdays, so still works with the full-time schedule. And they do Thursday evenings and on Saturdays. Our land surveying certificate is a brand new certificate. It's not something that we offered before. We've had surveying classes for a very long time, for 35 years, I think. So we've had them for a very long time, but we're always updating technology, and there's a need for surveyors in the industry right now, so we will get this certificate to build off of our engineering technology. I will say, so our mechanical engineering technology and civil engineering technology, they do have a transfer opportunity. So ODU, Old Dominion University, has engineering technology programs. So you can go and get a bachelor's in civil engineering technology or mechanical engineering technology. Same thing with guaranteed admission. You do 2 years with us, 2 years with them. And they are on our advisory council as well. So they work with us on classes to make sure that you're going into their program as a junior. The difference between a bachelor's in engineering technology and a bachelor's in engineering is really depending on the company that it's going to hire you. If you have a bachelor's in engineering technology, you could still become a professional engineer. I think it just takes a couple more years experience in order to take that exam. So there is a great opportunity if those math classes maybe are a little scary, then this is a route that you may want to take, or you may want to look into. We do advise students that if you're not sure, then to enter into the transfer program. And if maybe it's just a little bit too much or you want to then go a different route, the engineering technology program is a great way. And anything that you take in transfer will apply for the technology. We go through the programs.
Yeah, we do. I just want to add, after the communication with local businesses, a lot of our adjuncts program are actually part of that. So they're helping us guide the program to make sure that we're giving the students what they need from their education, but actually also helping administer the education as well, which I think is a brilliant question.
What's the estimated time for the next phase? So,
It will start this fall.
Cool.
So it's a 1 year certificate and it will start this fall.
All right, so this is our general question.
Yeah, so in all of our technology programs, you've got to take a class on technical drawing. Any type of engineering has to have drawing. And usually that's a 2D AutoCAD drawing. Then you're going to take some Inventor, which is 3D modeling. You're also going to take statics and strength material. So you see a lot of the same concepts within the transfer and the technology, but a lot of this is applied. We're not getting into the very hard calculus type problems. We're using kind of the data books and the things that already exist in order to still help you solve those engineering problems. So mechanical engineering technology is one of our programs. Our civil engineering technology is another one. Again, you're taking a lot of the same classes, but here you are also taking your surveying 1 and 2. And you're taking a lot of civil engineering technology electives as well. So mechanical engineering technology and civil engineering technology, these two still have that transfer opportunity. So we have a lot of students who take advantage of that. And then computer-aided drafting, this is where you're getting 4 different types of drafting software. You're getting a 2D drafting software, you're getting a 3D modeling software for on the mechanical side, kind of making parts and things like that. You're doing Revit, which is a civil architectural a software where you're actually building a commercial building or building a residential building. We have parts. I mean, it's basically you take the whole design in Revit, and then it can spit out a lot of information for estimating. And then we are going to be starting a civil 3D software as well, which is more on the land development side. So 3 different types of modeling software. You are very marketable to companies if you want to be a drafter, because it means that you know how to work around and actually like build these drawings so that you can communicate that design. And so this is also one of our great programs, not transferable to a 4-year, but very hireable.
We actually have they specifically wanted people to have associates.
Yeah, Army Corps of Engineers. So yeah, we have people that email us about drafters. Every year I get emails looking for our recent graduates. So our drafting certificate, this is where you're only taking the drafting classes where you don't have the associate. Still a great way to do it. A lot of the companies are looking for the associates because they want to make sure that you can do more than just drafting. They want to make sure that you understand some of the design behind your draft and that you have the basic like English skills, technical writing, all of those concepts as well. So the certificate is a great option, and it's a 1-year certificate where you're taking 3 classes in the fall and 3 classes in the spring. And then our brand new land surveying certificate, and this you're taking our surveying classes. You're also taking a GPS class, your civil 3D land development software as well. So this is our brand new one that we have gotten a lot of feedback from the industry. There's a lot of surveying apprenticeships that are no longer happening, especially up in Fairfax County. They got rid of their apprenticeship program. So a lot of people are looking for ways to educate surveyors. And a lot of times our surveyors are actually working, but they need this education in order to be able to pass their examination in order to become an actual surveyor.
So that was it from the degree programs we have for the engineering technology side. Were there any questions?
On any of these ones?
We'll have time for questions at the end too. So our last two slides here are from outreach events that we hosted. It's not part of your education. You don't have to do any outreach volunteering as part of your degree. But I think it's a really, really cool opportunity for students engaged in the program to also engage with their community. We are a community college. I think it's a really neat advantage that you're able to come here, learn, but also help others along the path. So this outreach event was at the Worlds of Work, which is at Shenandoah University. And these were all middle school age students who were coming through and learning about different career paths. We set up a table about engineering. And you can see we have the students working on a Arduino project, which is the microcontroller we use in the first year engineering design class. And you can see all of these are students who are explaining how the system works and what engineering is to middle school students, which I think does two things. One, it helps them be better people and help the community. But two, if you learn something, that is completely different than teaching something. So by you having to explain how something works, you are developing a firmer understanding of how it works. So I think it's a really good opportunity for the students.
Yeah, and so these are our students, our Laurel Ridge engineering students, teaching eighth graders about these little systems. So we were there, but really the students are the ones doing the rest of the work. And it's really good to see them behaving that way.
Students having fun.
Yes.
Good free lunch that day. And then this was our Laurel Ridge Exploring Engineering Summer Camp. We hosted this last summer for the first time for high school students in the area. And the pictures here are us working with the high school students, but we did have some current engineering students help and volunteer. It's just another example of an opportunity where our students get involved with volunteer work and assisting the education process for people who are a little bit younger. So with that, we would like to put a couple plugs forward for if you want to learn more. We have links here for learning more about what your next steps are to becoming a student here at Laurel Ridge. And then we have our contact information for myself and Professor Palpy as well. And we do have some time allotted for any questions you guys have.
Are you guys thinking about coming to engineering? Would be interesting.
Well, we appreciate you guys being here. We're gonna fill around for a little bit. Oh, there is no chat. What is the best way to get signed up?
Go to that. Future students, right?
Future students link, and go through the application enrollment process.
If you have any questions in the pathways, I'm typically the person who answers that, so I can give them additional information.
Yep.
So if they click on the pathway, the career, any of that stuff, if they submit their question, I'll give them stuff.
Awesome. So if you look at that, we can look at the pathways too, just so people know where to find that curriculum information. You just do the same and then get started.
Well, this
Go to program. Right there, engineering, science, engineering, math. So here you can find our different programs. You click on engineering, you would see the engineering page, and then you can go through, there's the description, there's a spotlight of one of our students, and then there's our program information for you. So all the courses that you saw in the presentation, everything comes from here, and everything is on the web.
and additional questions, I can answer them.
Perfect.
Typically, I give them out of.
Yeah, so if you have questions, you can go here.
Also, in those view books, the last page of my face,
One more
if you want to message me directly, you can. Or if you're eating a bun cake, if you open it up.
And then we do the sign.
So for engineering transfer, you're required to take calculus 1, calculus 2, calculus 3, which is multivariable calculus, and differential equations, as well as linear algebra. So there are 5 required math classes in the engineering transfer program. They are required by all 4 years, so there is not very much compulsion in that. If you're gonna do engineering technology, which is the applied degree, you can be taking a technical math class or pre-calc. So pre-calculus qualifies, pre-calc 1 and pre-calc 2 are the two math courses for engineering technology, which is the applied. You don't have to take calculus for the applied one. But for transfer, you do.
And the two mechanical and civil, you need to statistics.
You take statics, not statistics. So they don't require statistics,
Oh, they don't apply.
not for the transfer.
Is that for both UVA and Virginia Tech?
Virginia Tech does not require it for transfer. When you get there, I think it's an option depending on what track you're going into within civil. Because in civil, you can do structural, you can do transportation, you can kind of,
What
your
about
elective. Mechanical engineering does not require statistics. None of them require statistics.
And the UVA required? You don't need to take it.
You don't need to take statistics. I think they'll give you credit for AP statistics or for dual enrollment statistics, but it's not a requirement to get transferred.
What I've seen is a lot of it now is like push statistics on the student thing. If you, oh, you want to take this course, well, you take it too.
Yeah, especially if you're gonna end up doing, like pursuing your master's after your bachelor's, you will have to take statistics because there's a lot of statistics in that. But it is not a requirement for guaranteed tuition.
Brilliant.
I think I took statistics as a junior.
I took it
Right.
from what I saw from engineers. I mean, engineers are hired to design and build things, but are also hired to measure and analyze things. And as soon as you try to do that, you need a foundational knowledge in statistics. So it definitely is incorporated in the engineering curriculum quite a bit.
We do cover some basic statistics and evaluation stuff.
Any type of lab we do, if we make multiple measurements, we need to understand how to pull standard deviation, range. It's all needed.
So it's kind of built into the engineering curriculum, but it's not a math option. It's just
Any other questions? Well, we'll be here for a little bit, just kind of wrapping up. If you guys have any follow-up questions, and our contact information is up there. So please shoot us an email. Good luck with your decisions. You guys will all be great. Yeah.
I did have a question. Okay, so if for some reason like course is not, I'm not able to course or something like that because of something, or I need to go and take like a top one and calculate this in the same semester, but they don't offer it in that semester, something like that. If I wanted to go to a different community college, let's say Nova, that's standard. How would those credits transfer? Is there a limit how many credits I can take from a different community college to be able to apply for the associate of science in this college? Or?
I don't think so. I will say most of the courses are offered both fall and spring. With us, with the exception of our engineering electives. So that's where you get into more of either fall or spring specific. Most like Calc 1 is offered fall, spring, summer. Calc 2 is offered fall, spring, summer. A lot of the prerequisite classes we try to offer multiple semesters just because we know it's a gateway where you have to get that class in order to qualify to take another class. I know that we have students who do that. We do have shared services as well. So if it's a specific requirement, you can work with your advisor to help with. So you're still going through the school and then you don't have to worry about it transferring it or not because you're still signing up.
So how would that work? I would go in through the advisor to essentially attend class and a different college or
So
the
shared,
counting of this or up to count for the same class here, but just not active.
yeah, so shared services is all virtual learning. So it's all online course based. If you wanted to take the course in person, then you have to go to that community college and then transfer it. Now, any of the course numbers will all transfer in straight into the program.
Credits and everything else.
Yeah, I don't know if the grades transfer. Yeah. We would have to find out.
But it if I had to take an engineering elective at, let's say, Silver at the analysis of tech or something like that, and I took it there, I can transfer that course into Laurel Ridge.
As long as
Totally.
it's the same course.
As long, yeah, so we're
Yeah.
quickly engineering, fundamental, introduction to engineering. There, I can transfer it into here as that same course,
Yeah, as long as it's the same course number.
and it counts for the associate.
Yes, yeah, so it counts for the associate. So across the BCCS, we've standardized the engineering courses. So every BCCS school only can teach EGR 121, which is your foundations of engineering. So whether you take it with us or Nova or anybody, everybody will transfer it in the same. Every 4 year will transfer it in the same. Doesn't matter which community college you go to now. Everybody's teaching. the same course.
There's no limit for somebody to want. And do the design work, they put it off the line. Some other.
Yeah, there's no, I don't think there's a limit. You
Okay,
can transfer in as many credits as you have, as long as it's the same course.
I was wondering.
Yeah.
That's not a good question.
Yeah.
Sometimes, it's just why we put different courses, different college. And something.
Yeah, and we have students who work in Northern Virginia, maybe it's easier for them to get there right after work one day or. Yeah, all of the community colleges are teaching the same curriculum nowadays. In engineering technology, it's a little harder because most of, like Nova doesn't teach most of those classes that we teach. They're all different.
Any other questions?
The biomedical, you mentioned, I guess, Virginia Tech, I guess maybe James Madison, they have a biotech program as well, or biomedical.
I am not positive.
Okay.
So.
Well, I mean, internet says they do, but I just wonder if you had any experience.
So we don't have many students who go to James Madison. I think they have very small engineering school right now. I don't know if they're ABET accredited.
Gotcha.
Which is usually what pulls a lot of the students. We'll say Shenandoah has started a computer engineering program, which is new, but again, not ABET accredited. But that doesn't mean it's not a great program. So there are other schools out there. Most of our students will choose Virginia Tech. We have a handful that go to UVA, and then George Mason is another one.
But, so we have like articulation agreements where in place, if someone goes through our program, leaves with their associate's degree, they have the right position. That doesn't mean that you can't transfer to another school that we don't have an agreement in place. You usually need to go through the process of sending them your entire transcript, and sometimes I might ask for a course description saying, well, what was covered in your circuit scoring course, and then you send a syllabus. They go through and approve that. So it's non-guaranteed, and it's a little bit more of an indirect route, but that does happen. We had a student who graduated last spring and went to a very small aerospace school for them, which obviously we have not had articulation agreements with before. So she was able to make that work. I think we would be fine. They're just not that guaranteed.
And the guaranteed admission we talked about is guaranteed admission into the colleges and schools of engineering. There are a lot of guaranteed admission into the actual school. I think we have one with James Madison. Yeah, okay. But it's not through, it's not like into their college or here. It's just into their. So a benefit is, I mean, that Tech getting into the College of Engineering, getting into Virginia Tech is one thing, and then getting into Virginia Tech's College of Engineering is another thing. So it's the guaranteed admission into the college.
Thank you.
Yeah.
So that's the difference. That was Virginia Tech doesn't have a law. Virginia Tech is the only one that you have an agreement with. For original agreement, we can go in and go straight into the engineering school.
Virginia Tech, UVA, and VCU.
Oh, so UVA also has it?
Yep.
So if I went into UVA, then.
They require 3.4 GPA. So they do require GPA.
And so that's the case. Now, if I go to that, do I still need to from there apply for a specific civil, mechanical, whatever?
When you apply, I think you specify your degree program. They haven't specifically said, I think you do go straight into their degree program. I don't think you go into like the College of Engineering, you go into your mechanical, civil. But that is not something that they've specified. It's just that you're into the college.
So what are the big differences from getting to the degree pathway to the guaranteed into mechanical engineer? Then you have the guaranteed into, the guaranteed into the engineer.
Yes. The guaranteed under College of Engineering may not be the discipline that you want.
So that's what you can guaranteed into long term, you guaranteed into mechanical, versus you can get into CBA, get into their engineering. But you're not guaranteed to get into long term mechanical, you're not guaranteed to get into there.
Yeah. It doesn't mean wrong things.
Any other questions? Well, we appreciate you guys being here and choose us. And, that's it, right? But regardless, good luck with your,
Is there a way I can take you, days or whatever the.
yeah, we'll make sure it's, all right. Thanks, guys. Have a great rest of your day.
Just a small point. So these are the.
Five, one, one.
Take it. So